All right, good morning. How's everybody doing today? Good, fantastic. That's awesome. And if you woke up 2 minutes ago, then probably not too much bad stuff has happened. All right, good deal. So I posted your first week-long programming assignment. That's homework 3. We're going to spend a lot of today going over that. But any questions on homework 2 or anything else we've been going over? Someone said they have to pause their music. You don't have to pause your music to listen to my lectures, I don't think. That
That you can go over it, but so I added my SSHP to GitLab, and it's still when I try to like push stuff like the push origin master, it's still saying that access is denied.
okay. Let's look at that on Zoom. Um,
So like when your next office hour, I think is Friday tomorrow.
yeah, I could meet you right at 12 today if you want.
12 I'll be working.
Okay. Yeah, shoot me an email and we'll either figure it out through email or we'll find a time to screen share on Zoom.
Awesome, thank you.
Okay. All right, any other questions? So someone just commented that the problem could be trying to use a different key, and if you have multiple keys set up, that can be an issue. Um, and if you add the wrong origin or the wrong username, you can say git remote remove origin, and then start over again. Or you can just delete the whole directory and make a new repository in a new area. But git remote remove origin should work. Welcome. All right, so ODPs are done for the week. We'll come back with ODPs next week. I won't post ODPs over the weekend in general, although I might post one that opens Monday morning. Okay, but I won't surprise you with one on the weekend. Um, let's see. So ODPs are good. Homework 2 is due tomorrow, so hopefully everybody's got homework 2 done. That's the basic Git repo setup. Sending me an email, adding me as a reporter. I'll download those tomorrow. I'll send you feedback if I can't get to your repository for any reason. All right, so let's talk about homework 3, which is your first long programming assignment. So I usually do like 5 programming assignments in this course. I might do more this quarter. We'll see. But let's go through homework assignment 1, which is actually homework 3. So it's on Canvas, but I'll bring it up here. So you're going to make a shell script which plays a game with the user. And the game is called Stick. And it's a stick picking game, so you've probably played this before. Basically, you have a pile of sticks, toothpicks, matchsticks, something, right? And each turn, each person is allowed to take either 1, 2, 3, or 4 sticks. You have to take at least 1, you can't take more than 4. And then the goal is to be the last person to take a stick. Okay, very simple game. So if you were playing this, on paper, you might start with 12 sticks. All right, so maybe I'll take 1 stick and you'll take 1, 2, 3, 4 sticks. and I'll take 2 sticks, and you'll take 3 sticks, and then I'll take the last 2 sticks, I win the game. Right? So you're trying to take the last stick, but you're also trying to prevent the other person from being able to take the last stick. And there is a strategy you can use to win this most of the time. So you're going to implement this game in a bash script, and it's going to play with a user. It will let the user pick a number of sticks, it will pick a number of sticks, and so on. And it should be set up so that unless the user knows exactly how to defeat this, the game will always win. So the script you come up with is just called stick, and you run it without any arguments. And so let's go ahead and see what this should look like. Alright, so I'm going to run stick. It says, welcome to my matchstick game. How many sticks would you like to play with? And you put in a number, it's got to be at least 10. Okay, so I don't know, we'll play with 30 sticks. And it says, who should go first? Either U for the user or C for the computer. And if you don't specify, you should wait until the person either says U or C. Okay, it's got to be a lowercase u or a lowercase c. And you keep asking them again and again and again. Okay, so this is all part of the spec. And we'll see it in writing shortly. But basically, keep asking them until they say either, okay, computer can go first. Alright, or you. Okay, show them what the initial pile of sticks looks like. Here's 30 sticks. Tell them how many sticks there are in parentheses. And it says the computer takes 1 stick. That leaves 29. Okay, how many sticks am I going to take? Well, I'll take 3. Okay, now it says after I took 3 sticks, the remaining pile was 26. And then it says, I take 1 stick, and now the remaining pile is 25. Okay, I'll take 4 sticks, the computer takes 1, so now the pile is 20. I'll take 1, the computer takes 4, so the pile is 15. I'll take 2, the computer takes 3, the pile is 10. I'll take 4, that left 6, the computer took 1, the pile is down to 5. I've lost the game now, right? However many sticks I take, the computer's going to be able to take the last stick. So I'll take 1 stick, the computer takes 4, remaining pile is empty, and the computer says, I win. Alright, let's play with 20 sticks, and I'll go first. And I'll take 4. Oh. Let's play with 21 sticks, and I'll go first, and I'll take 1. So there's 19 sticks. I'll take 4, I'll take 4, I'll take 4, I'll take 4, and so now I won. Right? So you play the game, you show the pile of sticks as it's going along, the script makes moves, says how many sticks it's going to take, shows what the pile of sticks looks like, and you play until somebody takes the last stick, and then you announce who won. Okay, that's the basic setup. So, written out in detail, the game should greet the user, ask how many sticks to play with, integer bigger than or equal to 10, ask who goes first. Invalid answer should cause the program to repeat the question as many times as necessary. Okay, on the user's turn, ask how many sticks to remove, and remove those from the pile. On the computer's turn, calculate the correct number of sticks to take, remove those from the pile. Play until there's no sticks left. You must show the set of sticks after each player's turn, with a set of pipes, followed by the number of sticks in parentheses, so I don't have to actually count up the number of sticks. Alright, illegal moves, so very specific handling. If the person specifies an invalid number of sticks to play with, or doesn't specify U or C, you keep asking them as many times as it takes, okay? But once the game is playing, they have to say either 1, 2, 3, or 4 sticks. If they put in an invalid entry, they get exactly 1 chance to correct it. If they put in an invalid entry twice in a row, the game is over and the player loses. Okay? If they put in an invalid entry, you warn them, they put in a correct answer. The next time they make a mistake, they get 2 chances to specify a valid move. So how does that play out? Let's play with 340 sticks, and we'll let the computer go first. Okay, so I'm taking 12 sticks. That's cheating, okay? I can say, oh, I meant 2. Okay. How many sticks should I take now? I'll take 335. That's cheating. Okay, I meant 3. Okay, so they can mess up once. Okay, if they mess up twice in a row, kick them out. Game's over. They forfeited. Okay, this is a chunk of your grade, is being able to follow this specification and implement this exactly. And it's just a matter of coding up the logic correctly, okay? But it's another aspect of the assignment. So make sure you're clear on that, okay? 2 illegal entries in a row once the game is playing, and the game's over. Alright, so how do you help the script win the game as much as possible? Yes, we're writing this in Bash. Alright, how do you write the script so that the game will win if possible, right? Really simple algorithm. Okay, when it's the computer's turn to pick, however many sticks are left, take that many sticks mod 5. If there's 17 sticks left, take 17 mod 5, that's 2. Take 2 sticks. Okay, the one exception is if 17 mod 5 is 0, if the number of sticks mod 5 is 0, you're not allowed to take 0 sticks, so take 1. Alright, so if n sticks remain, if n is not divisible by 5, take n mod 5 sticks. And if you remember how modular arithmetic works, n mod 5 will always be 0, 1, 2, 3, or 4. Okay? If it's not 0, it's got to be 1, 2, 3, or 4. That's going to be a legal move. A legal move. So if n modulo 5 is equal to 0, take 1 stick. And the whole reason this works is because if it's my turn and the number of sticks left is 5, right, I can't win. I can only take 1, 2, 3, or 4 sticks, which is going to leave you with 4, 3, 2, or 1 sticks, which means in your next move you can always take the last stick. So as soon as the number of sticks left for my turn is a multiple of 5, I've lost. Right? Because if there's 10 sticks left, we can do the same thing. Whatever I take, you take enough to bring the pile down to 5. If there's 20 sticks left after my turn and your turn, you can force the pile to 15. The next pair, you can force it to 10, and then 5, and then 0. We'll dabble with this in CSE215, by the way. Alright, so your goal as the script, as the computer, is try to force it so that when it's my turn, the human turn, the number of sticks left is a multiple of 5. How do you do that? See how many more sticks there are right now than a multiple of 5 and take that many. If there's 17 sticks left, take 2. Now it's the player's turn. There's only 15 sticks left. You can force them to lose. Alright, if it's the computer's turn and the number of sticks left is a multiple of 5, the computer is on track to lose. And if the player knows what they're doing, that's it. They can force the computer to lose. But if they don't, they might make a mistake and turn things around where the computer can win. So if number of sticks left is a multiple of 5, just take 1. Because that will extend the game possibly longer and give more time for the user to mess up. Okay, so that's the basic algorithm. All right, other requirements. So a program must be written as a bash script. This isn't really a requirement, but make sure you make backups along the way. Okay? By whatever system you like, by making directories, by putting things on flash drives, or ideally by using Git. But make sure that if something goes wrong, you have a way to recover it. Okay? I've had students, who write me the morning an assignment is due and say, I was adding comments and I messed up and all my files got deleted, right? That's a horrible feeling. So do backups, okay? You must comment your script thoroughly, okay? So bash, right? You make comments by just saying $, and then you can put anything you want, and this can be on a line by itself, or it can be after a line of bash code, okay? I want to see lots of commenting in your code. This is not, 1,000 lines of bash, but it's not just a hello world either, okay? There's going to be logic, there's going to be looping, there's going to be cases to worry about. I want commenting throughout the code telling me what's going on in different sections. And we'll come back and visit the idea of commenting throughout this course. But let me give you an example. Right? What's going on here? Well, presumably S is the number of sticks. I'm finding out how many sticks we have modulo 5. I'm subtracting that from the number of sticks, and I'm setting the number of sticks equal to that again. Right? To somebody who doesn't know what you're doing, if they look at your code and they see this line, it's just gobbledygook. It's gibberish. They don't know what's going on here. To you coming back to this a year from now, you're going to look at this, you're going to be like, what the heck is that? Right? So a few things, right? Use some variable names. Right, to make things a little bit self-documenting, right? But throw some comments in. Okay? So what is not a really useful comment here? All right. That's not really an insightful comment as to what's going on in your algorithm. Okay? For somebody who doesn't know the bash language, this tells them what this says to bash, right? But to anybody, including yourself, who knows how bash works, if you look at this, what's it doing? Well, it's setting sticks equal to sticks minus sticks mod 5. You can see that from the code very directly. So putting that in a comment, not terribly useful for understanding what's going on. So that's not very insightful. So what might be a more useful comment here? Find number of sticks necessary to reduce pile to a multiple of 5 and take that off from the pile. Right? And I would probably break this up, right? I might do something like this. Take equals sticks %5. And a comment, take this many sticks. To reduce pile, to reduce number to multiple of 5. Right? You could put a whole paragraph before this. Right? If the number of sticks on the user's turn is a multiple of 5, we can always force it to another multiple of 5 and eventually to 0. Therefore, whatever the number of sticks are in excess of a multiple of 5, we should take that many. And then put this line of code in and, put a little comment on there. Now you've got, documentation inside your code. Right? A lot of code is more documentation, more comments than actual executable code. Go look at the Linux kernel, right? You'll see 10 lines of comments and then 1 line of code. So this is something to think about, right? It's a big shift of gears in some ways, but it can be really useful. All right, so commenting, really key, and I'm going to look for it in this assignment. Okay, and again, try to make the comments something that speaks to why you're doing something, not what your statement is doing, but why are you doing it? Why am I setting t equal to t plus 1? Well, a comment that says increment t doesn't tell me why I'm incrementing t. Count how many turns have been taken. All right, now I know exactly why you're incrementing t. T must be the number of turns. And if I call that variable number of turns and I increment that, and then I put a comment saying, you know, count how many turns have been taken, there's no question now. I know exactly what that line of code is doing. All right, so think about it from that mindset. And we'll come back and we'll talk about commenting throughout this course. In addition to all of those comments on the code itself, I want a comment block in the beginning. Okay, very start of your stick script, after the shebang, I want a block of comments. So so let's suppose this is my stick game. Okay, so it's homework 3, not 33. All right, homework 3, CSE224, October 2020. Give me your name. And then tell me what this is in your own words. So give me a synopsis of this script that you've written. Okay. Right? Be wordy here, okay? The idea is somebody picking up this script, like you know, a year from now, or if you give this to somebody as an example of your work, should be able to look at this and know what's going on in this program, right? So I want this comment block in the beginning containing your name, the course, the date, the assignment number, and a synopsis in your own words of what the script does. And I'm looking for more than just stick game, right? Or play a game, or bash script, or something like that. I want something so that somebody who knows nothing about homework 3 can look at this and come away with a pretty good understanding of what's going on. You don't need to describe every single nuance up here. You don't need to say if the user makes 2 illegal entries in a row, right? You can document that in the section of your code where you deal with that. But something so that somebody who knows nothing about this can get an idea what the script does. So this is a stick picking game. The user takes turns with the computer picking sticks. Goal is to pick up the last stick. You can take 1 to 4 sticks each turn. Something like that. All right, so think about commenting. Try not to do it at the very last minute. If you do it at the very last minute, please test your code after you've put the comments in. Because I always have students who turn in code that does not run. I try to run it and it says syntax error, because they forgot a number sign in front of a comment. So make sure the version that you turn in, you've actually tested. And if you forgot to add comments and you go and you put some comments in, test your code again before you submit it. Okay? All right, submitting your code. This is similar to homework 2, so you're going to submit through Git. So make a Git repository named HW003, uppercase, no spaces. Okay. Go into a new directory, start your homework 3, git init, git remote add origin, make a readme if you like, add that, commit it, push it over, and then go on to GitLab, set me up as a reporter for the project. So someone asked, is there any utility to a README versus commenting your code? Yeah, there kind of is. A README is something you don't have to go into the code to look at. If you're looking at Git, the README is always displayed on the front page of the project if it's sitting in the top level directory. So that when you first open the repository, you can see, what the person wants to tell you about it. And your code, might be split out over 50 different files. and you might have to, hunt around those to figure out where the main program is or where the main description is. And the README is sort of a higher level discussion of the project at large, right? Whereas oftentimes the stuff you find in the beginning of a file of code, a script, a C file, and so on, is related to that particular piece of the project. Your README can also have things, like formatting, bulleted lists, hyperlinks, stuff like that. All right, so this is due a week from today at 8 o'clock in the morning. So I will make a deal with you. If you get your Git repository set up this weekend, before Monday morning at 8, okay, you can send me an email and say, hey, I think my repository is set up. Can you try to download it? And I'll go in and I'll try to download it, and I'll let you know if you're set up or not. Once you're set up, you don't have to worry about it anymore. It's just git add, git commit, git push. Okay? So if you set it up this weekend and you send me an email before Monday morning, I'll be willing to go in and see if I can pull down your repository. Okay? That's a bribe to get you to set this up early. All right? Otherwise, you get all the stuff done, but maybe you forgot to add me as a reporter. You got no way of knowing until you get my email next Friday afternoon saying, hey, I can't download your project. Okay? All right, so set all this up just like you do for homework 2. You don't need to send me an email this time because I already know your GitLab ID from homework 2's email. Okay, so just add me as a reporter, and when I go to grade this next Friday, right, I'll run a script which, based on the username that you've already given me, will go and try to download a repo named HW003 from your GitLab account, and then I'll go ahead and grade that. All right, that's a lot of stuff. Any questions on any of that? All right, so let's talk about a different topic. So let's talk about backquotes. So this is a bash thing. Got new mail, cool. All right, so there's 3 kinds of quotation marks on your keyboard. There's a single quote. There's a double quote. Okay, we use quotation marks to keep things together. So if I run my argument test code from a few days ago and I say double quote hello space there, that forced hello space there to be a single argument, right? Whereas if I didn't have quotes around it, it would be 2 arguments, hello and there. So we can group things together with double quotes, but inside a string, a $sign is still interpreted as, let's find the value of a variable, for example. Let's see, question. When we create a new repo, do we need to create a whole other SSH? No. Your SSH key is once per machine. So you're all set with that. New repo, the only thing you need to do is git init and git remote add origin. And be in a new directory, right? If you're in a directory that already has a project in it and you try to git init, it's going to get confused. If you try to git remote add origin, it'll get confused. So make a new directory, git init, git remote add, and then you're off and running. All right, so let's do some stuff. So x equals 12. Echo quote x equals $x. Shows me x equals 12. The $sign is interpreted as replace $x with the value of x. Okay, so I can do that. And sometimes the double quotes aren't necessary. Okay. Single quotes, on the other hand, say pretty much just take what I've typed in literally. So this will output x equals $x. So double quotes group things together but allow interpretation of, say, $sign variables. Single quotes say just take this thing literally. Alright, there's a third kind of quote. This is called a backquote or a backtick. So on my keyboard, this is under the tilde. Right, so it's this key right here. It's way off in the corner. We don't seem to use them very often. And backquotes have a special meaning. So, for example, I take the date command and I execute that. It shows me the date. Okay. If I say x equals date, and I look at the value of x, it's DATE. If I say x equals $date, x is nothing. Why? Because date is not a variable. And so the value of that $date is just empty. But what I'm trying to do is get this stuff into a variable x. In other words, I want to run a command, and I want the output of that command to go into a variable. Alright, so this is what backquotes will do for us. So check out this action. X equals backquote date backquote. Now if I echo $x, it shows me what the result of running date was. So backquotes are a way that we can capture the output of a command and save it in a variable. And it's just a variable. It doesn't change based on the current date. It's simply a capture of the output of, in this case, the command date. If I say x equals backquote pwd, x is a variable that contains the name of my current directory. If I say x equals backquote ls, and I look at the value of this variable x, it's a list of the files in my current directory. And yeah, the output was taken when I said x equals backquote date. So when you say something, when I hit enter, this command will get executed by bash, and instead of showing me the output on my screen, the output will be captured and sent basically into this variable x. But if there's any errors, I'll see those on my display. Those don't go into x. So in this case, x was nothing, right? It was empty, because this command didn't generate any output, because it's not a valid command. So if I say x equals backquote ps, x is the result of running the ps command. Well, I can see that you know, this is all on one line now, but I can see that I had a process named ps running. That's this command right here. Alright, so this is really useful. This is a way that we can capture the output of any command that we want. Almost any command that we want. Right? So I want to know how long the system's been up. I can say x equals backquote uptime. And that tells me how long the system's been up. And if I look at this, I can see I have 1, 2, 3, 4, 5, 6, 7, 8, 9 words get me up to the load average. So we'll talk about awk and sed in detail closer to the end of the course. But if I do this, I miscounted. I can grab the current load average. And so if I said x equal to this more complex statement, which says run the uptime command and then run it into this program called awk and print out the 10th column, right? All of that should generate something like this. And that output, instead of being displayed on my screen, should have gone into the variable x, which now has a load average. If I want to get rid of that trailing comma, I can run it through another program called sed, and now here's what the load average is. Right? And you can put this inside a script and do something like this, and then you could say, you know, if $x-gt1, right? Well, it's a floating point, but I could turn it into a non-floating point by manipulating it and then compare it to some limit and do something if the load average gets too high, and so on. Let's see. You could integrate this into a script, show certain information. Absolutely, yeah, that's part of the whole idea. That's one of the key things that we'll do with this. So question, if you define a variable in the command line, well, on the Linux server, is it global for all the users and does it stay after you log in and out? It does not. So if I say something like x equals hello, and I echo $x, it's hello. If I log back in, and I echo $x, it's nothing. And this gets into a bigger issue, which is subshells. Let's write a script. All right, really simple script. All it does is set x equal to hello. And I'm going to run that. Well, let me make this a little better. Let's echo the value of x just to make sure it actually gets set. So I'll run go, and sure enough, x is equal to hello. But if I look at the value of x, it's not hello anymore. All right, so why is that? The reason is when I say go, I happen to have a shebang in the top, which says this should be run with bash. If I didn't, it would run it with bash anyway because my current shell is bash. But the current shell I'm in, bash, starts a new shell, a new instance of bash, and feeds it all of this. That new bash shell is setting x equal to hello and then echoing the value of x, right? But that's happening in a different shell. It's a subshell under my current one. It's exactly like this. Start a new bash shell, set x equal to hello, echo the value of x, and then exit. Well, that has no effect on the value of x in my current shell because all of this happened in a subshell. That's what happens when you run a script. All right, so I'm going to change my directory to /etc. I'm going to say my current directory is, and I'll run the print working directory command to confirm that I'm in this new directory. So right now, I'm in my home directory. I'll run my script. It says hello. It says the current directory is /etc. But if I print my working directory, I'm still in my home directory. Right? Why is that? Because the go command ran in a new script, a new bash shell. And in that bash shell, the working directory was changed. Yeah, bashception. All right, so there is a way around this. We can use the command source. this can be a little, I don't say dangerous, but it can be a little easy to get some surprises with. But basically, if I just say go, create a new bash instance, feed the input of go to that new bash shell, and then come back. If I say source go, that says don't make a new bash shell, just read the contents of this file and execute it in my current shell. And that will be something that I'll see the effect of. So if I source go, right, it tells me x is hello, current directory is etc. Well, now if I echo the value of x, it is equal to hello. And if I print my current directory, it is / etc. And yeah, so somebody commented, and this is the same statement for me. Most common use for source is to re-execute your bash RC. Okay, so your bash RC contains all these commands that get executed when you first start your shell. If you just try to run it with, ~/.bashrc, it doesn't affect your current shell. So you can source it, and that will re-execute everything that's in there, and it will affect your current shell. All right, and all of this stuff is absolutely only for you in your current session. It won't affect anybody else. It won't affect you if you're logged in through another terminal window. It's all strictly local to this particular bash shell. All right, other questions about that? And so one thing this means is we can run a script and have that script produce output, and we can capture that in another script. So anything that a script produces by using, say, an echo statement, we can grab that by running that script inside backquotes. Right? And so even though things like variables and stuff like that are local to the instance of that script, we can grab the output and do useful things with that. So let's play with this. And this is just a idiosyncrasy of myself. When I write bash scripts, I put a shebang in the first line, and I just put this after it, just, I don't know, to visually separate it. It doesn't do anything. It's just a comment. But you'll see that in my code. So I'm going to write this this one-line script, which just runs the who command and counts how many lines of output it has. So I can say count users, and it shows me 19. All right, so let's write our Go script. And then going to echo current system load is, and then going to say backquote count users. Well, this string that says backquote count users is going to say, let's execute this count users command, let's take whatever it outputs, and we'll replace this whole thing, backquote count users, with the output. And so this echo statement should turn into echo current system load is 19, or however many users happen to be logged in. So we can start using functions the way we do in higher level languages like C and Java and Python, where we don't have to put everything in one script. We can make other scripts, helper scripts that do things, and then include those. So I have a script called "What class is this?" I tell it about my class schedule, right, which is stuck in a file, and it basically looks at the current date and time, does some parsing, and figures out what class I'm in. And I can say, "What class is this?" Assuming I can spell it correctly. And it'll tell me that I'm in CSE224A. All right, and I use that inside other scripts. Right, so here's my timestamp code, which is timestamping my videos, and it will run "What class is this?" right, and the current date and some other stuff, and it will put that into an echo statement. And that's where the CSE224 comes out in the beginning of those timestamps on the video list, right? So you can modularize your bash code just like you modularize C code. And modularization is another theme we're going to work on a lot in this course, okay? We usually don't want to write big, long, monolithic functions where we have one file that's, 5,000 lines long and does everything. We want to think about breaking our problems into subproblems, and usually each subproblem gets broken into further subproblems until we get down to very small pieces. Those are the pieces we want to code, and generally we want to code each of those things as kind of a standalone element. So timestamping videos, right? I want to know what class I'm in. I want to know what the current date and time is. I want to be able to get an entry from the user. I want to be able to paste everything onto the clipboard when I'm done so I can paste it into YouTube, and so on and so forth. Each of those things is a separate function. You can make a separate script that logically handles each of those, and then put those together to implement higher level functions. Then put those higher level pieces together to make something even higher level. So using backquotes around function calls is one way to pass information back from a script to the thing that's executing it. Can you use "What class is this?" in a different directory? Yeah, I actually can, because it's, I believe. I don't know why I had to dot it in the other one. Nope, no I can't. I don't have it set up as an alias. But like my timestamp program I have and my camera setup I have, I just set them up as aliases. If you don't want a million aliases, you can put this directory in your path, right, and put all your executable stuff in there. But I got too lazy to do that. So I just have a zillion aliases set up for doing all these different support functions. All right, any other questions in our 10 seconds we have left? All right, cool. Have a good afternoon. I will see you tomorrow. Thank you.